This is a quick review of application of rationals. So in this video we'll look at time together, time alone sorts of problems. You may remember seeing this formula that time together over time alone for one person added with time together over time alone for another person is equal to one whole job done. So this is what we'll use for the example we'll look at. Let's say we were given this problem. If Adam and Glenn work together, they can complete a certain task in 8 hours. Working alone, it takes Glenn 15 hours. How long would it take Adam to do the job himself? And we will round our answer to the nearest tenth of an hour. So given this situation and the formula we talked about briefly, let's see what we can plug in and what the unknown is. So in this case it looks like the time together was given as 8 hours. So I can begin by filling in the numerators with 8. And then the time for Adam, that's what we don't know. So we can basically let x represent the time for Adam alone. And we know that will be time in hours. So I can put x down low for Adam's time. We were given Glenn's time to be 15 hours, so I'll put that in for the time alone for Glenn. And this will equal to one whole job done. So there's our setup for this problem. If we use the strategy we've seen so far with solving rationals, basically we're going to be looking for a least common denominator. So in this case our denominators are x, 15, and 1, making our least common denominator 15x. So I'll just walk through the steps of changing each denominator to look like the LCD, and then we can essentially multiply the whole equation by the LCD, getting rid of the fraction part. So our first fraction needs the factor of 15, top and bottom. Our second fraction needs the factor of x, top and bottom. And the third fraction will need everything, the 15 and the x. So now we have the same denominator for all three fractions. At this point I'm going to go ahead and say we can eliminate the denominators. So if I clean up what's left in the numerators, that looks like 15 times 8, which is 120, added with 8 times x, so 8x, is equal to 15x. So this is a pretty friendly linear equation. So I'll go ahead and move to the next slide here to continue solving this. So we had 120 plus 8x equaling 15x. We're solving for x, where x represents the time for Adam alone. Since it's linear, I'll go ahead and move all my x's to one side. So that gives us 120 equaling 7x. And I'll divide both sides by 7. And let's see, if we divide 120 by 7 and we round off to nearest tenth, that should be about 17.1 as our approximation for x. So, going back to our problem statement, we were trying to find how long it takes Adam to do the job himself. So as I interpret our solution, I'll just write a little sentence and we will say it would take Adam about 17.1 hours. And we have answered the question, so hopefully that makes some sense. Happy studying!